I'm Matt Helmers with Iowa State University and Director of the Iowa Nutrient Research Center. I'm here with friend and colleague Chris Hay. Maybe Chris, you can introduce yourself and the organization you represent.
Sure, I'm Chris Hay, Senior Research Scientist with the Iowa Soybean Association.
So Chris, we're out here at a site. Tell me a little bit about kind of what we call this site or this practice that we're looking at today.
So we call this drainage water recycling, which is what it says. So what we've got here is a storage reservoir that's capturing drainage water from a drainage district upstream, and so captures it and stores it before it gets to the Raccoon River. And so with this storage, then we can pump out of this storage up to the center pivot that they use to irrigate this field with. And so really what it's designed for then is to capture water when we've got enough to use in times where we don't. And so that's the idea.
So if I'm not mistaken, this one captures both surface and subsurface flow from about 2,000 acres. And I think it came online about the 4th of July in 2021, if I'm not mistaken, when they kind of had things built and ready to be used.
Yep.
And even in, we're in western Iowa, or I guess west central Iowa. Even in these last 2 years, they've had enough water to be able to provide supplemental irrigation for the crop field.
Yeah, this one has turned out to be a really nice site for that both from the drainage district discharge as well as some of the surface runoff, it's kept it pretty well full. The other thing is he's got kind of a unique situation where he's got sandy soils on top of that clay layer. And so with the slopes on both sides of this, as that water infiltrates down to the sand, it hits that clay layer and then moves laterally, and then that helps refill the storage as well.
So this drainage water recycling concept, this is kind of a, in a sense, a unique site where it could be situated on the downstream side of that drainage ditch. Was this land used for crop production prior to putting in the pond that we see behind us, or storage facility we see behind us? The storage itself was in the waterway, and so that was, again, a nice convenient location where we could just create this embankment. We didn't have to take land out of production. The land that's irrigated, that has been in crop production before, but again, with kind of that sandy soil in the topsoil, there were lots of times where he would run out of water during the summer, and so having this supplemental irrigation then helps him get through those dry periods in the summer. Yeah. If I'm not mistaken, from our monitoring that we've done here, estimated rainfall is about 9 inches from kind of mid to late April through late September. So only 9 inches, not a lot for, especially on a sandy soil. Mm-hmm. But I think then they applied somewhere around 7 inches of water as supplemental irrigation. So by the time we have the virtual field day, we'll have the yield data to be able to summarize and share with folks as well.
Yeah, and one of the things that Mark does is grows popcorn, and so it's a little higher value crop, and so when you're doing that's a good incentive for having that irrigation. But when you're growing that higher value crop, you want that certainty of having water to get that through to full yield.
Yeah. So some of the projections I've seen are maybe wetter springs and drier summers. Might this practice maybe even have greater benefit if that kind of comes to fruition, if we see a little more of those types of years moving forward?
Yeah, absolutely. Climate resiliency is one of the big ideas behind this practice, and certainly we're already seeing that trend, and all indications are that trend's going to continue. The more water when we don't need it in the spring, and then more dry periods, longer dry periods in the summer. And so this practice really sets itself up nicely for that we can capture the water when we got it but don't need it, and then use it when we do need it later on.
Okay. And so this one we see behind us, there's a sump here and a pump that would pump to the center pivot. So this landowner, Mark, is familiar with center pivots, but that might be something that moving forward for those interested landowners, there'd be a little bit more operations and maintenance associated with this, because and maybe something new to learn about irrigation and pumping for irrigation water.
Yeah, certainly there's some irrigation in Iowa, certainly in the river valleys, not as much outside those river valleys. So yeah, irrigation is going to be new to a lot of people. Obviously, we're using the center pivot here that Mark has. Doesn't necessarily have to be a center pivot either, so there may be some other options for irrigation depending on the individual site. And so particularly flat sites, you may be able to just reuse the drainage system itself, and so put water back in through that drainage system, raise up the water table below the crop root zone, and the crops can access that water that way. So for some folks that may be an easier way to do that, but other sites are going to have to use something like a center pivot, or there's been some interest from some folks as well in subsurface drip in some situations. So really, you can use whatever irrigation system makes the most sense.
So something for all of us to research into the future, what might be the economics of the different systems, maybe for different crops in Iowa.
Yeah. So where sub-irrigation with the drainage system makes sense, that's probably going to be the most economical. If it doesn't work for that, if you've got a field where you can do a full circle with a pivot's often going to make the most sense there. Smaller, odd-shaped fields or higher value crops, then subsurface strip may make more sense in those locations.
Okay. So Chris, this is one of the sites. Are there other ways this could be done, or is this type of practice going to work at kind of all fields in Iowa, or what might be different ways that we could think about drainage water recycling?
Well, I mean, we are engineers, and so we can engineer something to work. Now, the next question then is how much it's going to cost. And so, certainly some sites are going to make more sense than others, and some are going to be cheaper than others. This is a site where, because we were able to create the embankment, it's a little cheaper than if we had to do a lot of excavation. Where we got to do a lot of excavation, storage is expensive, and so those sites are going to tend to be more expensive. Again, depending on the irrigation system, that's going to be a big factor in how we design the site, and then also how expensive it's going to be. And so, we could probably engineer something to work at most sites, but some are going to lend themselves to being more suitable than others.
And I'd say this is, you authored a Frontiers in Agriculture paper to kind of illustrate that there's a lot of need in this space, and I would say that might be one of those areas that there is a need to understand the cost effectiveness of this practice and understand, where it might work well and where it might not be quite as cost effective.
Yeah, absolutely. And I think some of the early research that some of the grad students here at Iowa State have done, looking at some of the economics, is it looks like maybe with kind of current corn prices that we're getting close to breaking even on the irrigation system, not including the storage. As we move forward in time, then a typical corn soybean rotation, then it's going to start to pay off that irrigation system because of those the concern about drought and longer drought periods moving forward in the summers. And so it looks like even on a traditional corn soybean rotation, we can get to where the irrigation system will pay for itself. Then the big question becomes, how do we pay for the storage? And so that's where I think the research on the water quality side becomes really important, because not only are we getting the crop production benefit from that supplemental irrigation, but by capturing and storing that water and recycling it, we're also preventing the nutrients that are in that water from going downstream and causing downstream water quality concerns.